Okay, so again, we want to get a function for each situation here. Well, if you notice the first one here, number 1, is this going to be exponential or linear?
Linear.
It's linear, right? And how do we know that? Well, because it's the value, the function value, right? The function represents the value of the investment, okay? That's changing by a dollar amount. It's changing by a dollar amount, a fixed dollar amount each time. Same thing with number 2, right? I mean, in 2, it's decreasing each year, but still it's a dollar amount. Whereas for number 3, right, the value is changing by a percentage. So that's how we know those are exponential. So here are the solutions to that. Namely, we have, as you can see, for number 1, right, the amount of change each time is the slope. So for number 1, $700 is the slope. The initial value here, as you can see, is $8,400. That's the initial value. So that's what we have here. That's our B. Same thing for 2. Except in 2, it's decreasing, so we put a negative in front of the slope. Put a negative in front of the slope. Now for 3, 4, and 5, again, those are exponential. For 3, it's changing each year. It's changing each year, right? The initial value is in front. Now, since it's increasing, it's 1 plus 0.065, as you can see. Whereas here, the value is decreasing. So we know we're going to have 1 minus. But since it's every 2 years, again, we have to divide. It's every 2 years, so we divide by 2. Again, X years later, we divide by 2. For 5, we have 1 plus 0.09 because it's 9% and it's increasing. But it's every 6 months, right? So that's 2 times in a year. So it's twice a year. So we have 2 times X. So that's what we get here. Okay. I hope that makes sense. So here's another, I guess, so-called fun example. I was going to have people try it on their own, but I think it's better if I do it with you guys. Not to say you can't handle it. For the other class, I did it with them. Mostly because I wanted to. They didn't ask me to or anything. But anyway, so let's suppose now, we have $1 and we invest it somehow into an account or something else. I don't know. But the investment value doubles each day. It's doubling in value each day. Okay? First thing we want to do is write a formula, f of x, for the value of that investment x days later. We're going to write a formula for the value of the investment. Well, notice, though, that this is going to be exponential because it's doubling in value. In other words, what you're doing is you're taking the amount. Wait, you know what? Here, let me show you. In other words, what you're doing is for the value of the investment, right? You're taking the entire amount and adding it onto itself. You're doubling it, as you can see. You're doubling it. So at times 0, which is now, it's worth what we invested. A day later, it's going to double in value, right? So what's going to happen is the value of 1, right? You're going to double it and you get 2. So in other words, you're adding on 1 to this. For the next day, you're adding the number to itself. So you're adding on 2. So you add that on. And then for the next one on day 3, you're adding on 4. So you're doubling. In particular, it's not linear because you're not adding on the same amount each time. Okay? So it's going to be exponential. But the question is, what is our R? Well, that's what this is. Remember the rate of, the relative change, right? F of 1 minus F of 0 divided by F of 0, that's 1. I mean, essentially what's happening is you're adding on the element itself. So you're adding on 100%. 2 to 4, right? You're adding on itself 2 to 4 to get 4. You're adding 2 to itself to get 4. You're adding on 100% of 2, and that's how you get 4, F of 2. To get F of 3, you take F of 2, and you add on 100% of itself. That's how you get F of 3. And that's really what this is saying. Okay, let me say that again. From 0 at F of 0 to get F of 1, you add on 100% of F of 0 to itself. That's how we get F of 1. From F of 1 to F of 2, right? You're going to add on 100% of F of 1 to itself to get F of 2, and so on. That's really what the ones here are telling us. I mean, here we have it as a decimal, not a percent. But R is going to be 1. R is going to be 1. So, okay, that's good. So, if R is 1, then this is our function. We're investing $1, so the front here is 1. No, excuse me, the initial value is 1. So we end up getting this, 2 to the x. Okay, so it's an exponential function. Okay, now we can ask, well, how much is this going to be worth 10 days later? That's what this is. 10 days later, we're going to get f of 10, which is 2 to the 10th, which is $1,024. Okay? So that's what we get here. All right, that's good. And now this is another, I guess, I don't know, I thought it would be a fun question, but would you rather receive how much you get after 20 days or take $1 million now? Really what I'm asking you is, which is larger, f of 20 or $1 million? Well, it turns out f of 20 by direct calculation is itself more than $1 million. So f of 20 would be a lot more. I think, in fact, if you got f of 30, if you calculated it 30 days later from the beginning, so f of 30, you would have $1 billion at least. So that's good. So that's what we get here. Okay. All right. Okay, so we have that. We just pause the recording.